In this video, we will learn about some problems related to planes. The first problem is find the equation of the plane, which is the rotation by an angle alpha of Lx plus my, which is equal to 0 about its line of intersection, which is equal to 0. Solution. The first, we will identify the line of intersection. The given plane Lx plus my, which is equal to 0, intersect the plane is equal to 0. Thus, their line of intersection is defined by the system Lx plus my, which is equal to 0 and is equal to 0. Any plane containing this line must pass through this intersection. Next, we have to write the general equation of the required plane. Hence, the required equation of the plane passing through this line is Lx plus my, which is equal to 0, and Lx plus my plus lambda is equal to 0. Then use of angle between planes formula. The angle between two planes is equal to the angle between their normal vectors. The normal vectors are n1 is equal to L, m, 0 and L, m, lambda. Thus, the cos alpha equal to n1 dot n2 is divided by modulus of n1 into modulus of n2. Substituting cos alpha is equal to L square plus m square plus lambda 0 is divided by square root of lambda square plus m squared into square root of L square m square lambda square. On simplification, we get cos alpha is equal to square root of L square plus m square is divided by square root of L square plus m square plus lambda square. Squaring on both sides, then we get cos squared alpha, which is equal to lambda square plus m square is divided by L square m square plus lambda square. Then rearranging lambda squared equal to lambda L square plus m square into tan squared alpha. Hence, lambda equal to plus or minus square root of L square plus m square into cos alpha. Then equation of the required plane is required plane. Substituting the value of lambda, then we obtain Lx plus my plus or minus square root of L square plus m square tan alpha is equal to 0. From the above, we conclude that therefore the equation of the plane obtained by rotating the given plane about its line of intersection with z equal to 0 is Lx plus my plus or minus square root of L square plus m square tan alpha, which is equal to 0. Note, this result demonstrates the effective use of families of planes, vector methods, angle relation is three-dimensional geometry. The next problem is based on plane through line of intersection and perpendicular to a given plane. The problem is find the equation of the plane through the intersection of the planes x plus 3y minus z, which is equal to 4, and 2x plus 2y plus 2z equal to 1, which is perpendicular to the plane x plus y minus 4z, which is equal to 0. Solution. In this problem, we are asked to find the equation of a plane that passes through the line of intersection of two planes and is perpendicular to another given plane. Solution. Let's solve this step by step. Given two planes are 3x plus 3y minus z equal to 4 and 2x plus 2y plus 2z equal to 1. Given two planes are 3x plus x plus 3y minus z, which is equal to 4, and 2x plus 2y plus 2z equal to 1. And the clear plane is perpendicular to x plus y minus 4z equal to 0. First, we have to write general equation of the clear plane. Any plane passing through the intersection of given plane can be written as x plus 3y minus z plus 4 plus lambda into 2x plus 2y plus z minus 1 equal to 0. Expanding, then 1 plus 2 lambda into x plus 3 plus 2 lambda into y plus minus 1 plus 2 lambda into z minus 4 plus lambda, which is equal to 0. Then applying perpendicular condition, then the required plane is perpendicular to x plus y minus 4 is equal to 0. Show the dot product of the normal vectors must be 0. The normal vectors are required plane 1 plus 2 lambda, comma 3 plus 2 lambda, comma minus 1 plus 2 lambda. And the given plane is 1 comma 1 comma minus 4. Then the dot product is 1 plus 2 lambda into 1 plus 3 plus 2 lambda into 1 minus 1 plus 2 lambda into minus 4, which is equal to 0. Then solve for lambda. Then 1 plus 2 lambda plus 3 plus 2 lambda plus 4 minus 8 lambda, which is equal to 0. Hence 8 minus 4 lambda, which is equal to 0, which implies lambda equal to 2. Then substitute lambda equal to 2 into the plane equation. Then we get x plus 3y minus z minus 4 plus 2 into x plus 2y plus 2z minus 1 equal to 0. Then simplify, then we get 5x plus 7y plus 3z minus 6 equal to 0. Hence, which is the required plane equation. We use the standard technique from form a family of planes through the intersection, then apply the perpendicular condition. This method is very powerful in 3D geometry problems. The next problem is based on locus of a centroid of a triangle formed by a moving plane. The problem is a moving plane passes through a fixed point alpha, comma, beta, comma, gamma and intersect the coordinate axis at A, comma, B, comma, C. Show that the locus of the centroid of the triangle ABC is alpha is divided by x plus beta is divided by y plus gamma is divided by z, which is equal to 3. Solution. In this problem, we study a moving plane that passes through the fixed point alpha, comma, beta, comma, gamma and cuts the coordinate axis at the points A, comma, B, comma, and C. We aim to prove that the locus of the centroid of the triangle ABC is alpha is divided by x plus beta is divided by y plus gamma is divided by z, which is equal to 3. First, let the plane cut the coordinate axis at a equal to a comma 0 comma 0, b equal to 0 comma b comma 0, and c equal to 0 comma 0 comma c. Then centroid of the triangle. Let the centroid of the triangle ABC be x1 comma y1 comma z1. Using the centroid formula, then we get x1 equal to a is divided by x1 equal to a is divided by 3, y1 equal to b is divided by 3, and z1 equal to c is divided by 3. Then the intercept form of a plane is x is divided by a plus y is divided by b plus z is divided by c, which is equal to 1. Then the plane passes through the fixed point. Since the plane passes through the alpha, comma, beta, comma, gamma, substitute then alpha is divided by a and the beta is divided by b, gamma is divided by 1. Then substitute in terms of centroid from the earlier. Then we get a is equal to 3x1 plus comma b is equal to 3y1 and c is equal to 3z1. Substituting into the equation, alpha is divided by 3x1 plus beta is divided by 3y1 and gamma is divided by 3z1, which is equal to 1. Then multiply both sides by 3. Then we get alpha is divided by x1 and beta is divided by y1 plus gamma is divided by z1, which is equal to 3. Thus, we have shown that the locus of the centroid x1, y1, z1 is alpha is divided by x1, x beta is divided by y plus gamma is divided by 3. This elegant result connects the geometry of planes with coordinate geometry and logging. Stay tuned for more 3D geometry insights.